Most metals are found in the Earth's crust in the form of its ores. Do you know how we can extract these metals? Observe the minerals that can be obtained from the Earth. The extraction of metals from the surface of the Earth forms a major industrial activity. Most metals are found naturally in the form of oxides. These metal oxides found in the Earth's crust are known as metal ores. How can we extract the metals from its ore? At the end of this lesson, you should be able to relate the position of metals in the reactivity series to the method of extraction of metals from their ores. Explain with examples the process of extraction of metals from their ores using carbon. State the importance of the reactivity series of metals. Knowledge of the reactivity series will help us determine the suitable method to extract metals from their ores. Click the metal ore to review its examples. The position of metals in the reactivity series is used to determine the method of extraction. In the previous lessons, we learned that metals at the top of the reactivity series are more reactive than the metals below them. Metals at the top of the series will be able to extract metal below it from its metal oxide. Observe the reactivity series. Identify the metals that can extract tin from cassiterite. They are potassium, sodium, calcium, magnesium, aluminum, carbon, zinc, and iron. This is because they are all placed above tin in the reactivity series. What are the metals that cannot be used to extract tin from tin oxide? They are lead, copper, silver, and gold. Which is the cheapest material in the reactivity series you would use? Carbon is placed in between aluminum and zinc in the reactivity series. Carbon is used to extract those metals below it in the reactivity series. Since carbon is available in abundance, it is an economical method of extraction. The extraction of zinc, iron, and tin from their ores uses carbon as the raw material. Let us take a look at the word equation for the chemical reaction that takes place when using carbon. Metal oxide reacts with carbon to produce metal and carbon dioxide. Since carbon dioxide is a gas, the product that is left behind is metal. Write the word equation for the reactions that occur in hematite and cassiterite. Iron 2 oxide reacts with carbon to form iron and carbon dioxide. Stannum oxide reacts with carbon to form stannum and carbon dioxide. How do we extract the metal in bauxite? Bauxite is aluminum oxide. The extraction of metals above carbon in the reactivity series is done through the process of electrolysis. Metals are often found in their ores as sulfides. The sulfides can be converted to the oxide when heated. Metal sulfide reacts with oxygen, produces metal oxide and sulfur dioxide. For example, lead-2 sulfide reacts with oxygen to form lead-2 oxide and sulfur dioxide. So do metal carbonate. They decompose into their oxides, releasing carbon dioxide when heated. Metal carbonate produces metal oxide and carbon dioxide. For example, copper-2 carbonate to form copper-2 oxide and carbon dioxide copper-2 oxide react with carbon to form copper and carbon dioxide. For metals which are below carbon in the reactivity series, after the metal sulfide and carbonate decomposed to their oxides, we can heat the oxides with carbon to obtain the metal. Tin ore is called cassiterite. Malaysia used to be the largest exporter of tin. Which metals can be used to extract tin in cassiterite? Tin is extracted in the industry by using carbon. The extraction occurs in a blast furnace. Learn how tin is extracted by clicking the stages. Tin ore contains impurities. The ore will be grounded into smaller forms and washed to remove any stone and mud. The washed tin ore is heated to remove impurities like sulfur, arsenic, iron or copper. Tin ore is mixed with coke, carbon and limestone, calcium carbonate in the blast furnace. Heated air is passed through the mixture at a very high temperature. The high temperature will start the reaction between tin 4 oxide and carbon. The products of this reaction are tin and carbon dioxide. Carbon dioxide is expelled as furnace gas. Heat is given during the reaction. Calcium carbonate in the mixture will decompose into calcium oxide. This compound will react with other impurities like silicate to form slag. Molten slag will float on top of the molten pure tin, preventing tin from reacting with oxygen again. The high temperature will melt the tin. Pure molten tin will sink to the bottom of the furnace and is poured into mold-forming blocks of tin called ingots. We know that the reactivity series is important to identify the method of extraction. Those metals below carbon can be extracted by heating carbon with its ores. There are other important criteria. The reactivity series shows us the reactivity of metals towards oxygen. The more reactive metals will react with oxygen. Oxygen is abundant in the atmosphere. Knowledge about the reactivity of metals will tell us how to store them. Can you describe how to store potassium and sodium? From the reactivity series, we know that potassium and sodium are very reactive metals. They will easily react with oxygen when exposed to air. Both of these metals are stored in paraffin liquid to prevent contact with oxygen. The reactivity series will also enable us to predict whether a reaction can occur. What will happen when we put iron nail into the copper sulfate solution? There is a reaction. Iron is above copper in the reactivity series. Iron is able to extract copper from copper sulfate.
The Table A shows a list of metal oxides. Refer to the reactivity series to classify the ore that can be extracted by heating with carbon or by electrolysis. Write your answer in the classification table.
That's not right. Please try again. Your answer is incorrect. This is the correct answer.
Write the word equation that occurs for the reaction with carbon.
That's not right. Please try again. Your answer is incorrect. This is the correct answer.
Just like tin, iron is another metal that has many uses. The two common oxides of iron is hematite and magnetite. Iron ore undergoes a similar extraction process as tin ore. The diagram shows the flow chart for the extraction of iron from iron ore. Match the stage with the appropriate chart.
Your answer is correct. Your answer is correct. Your answer is correct. Your answer is correct. Your answer is correct.
Arrange the following metals according to the reactivity series of metals in the decreasing order: zinc, magnesium, copper, and tin. A. Copper, tin, zinc, and magnesium. B. Magnesium, zinc, tin, and copper. C. Zinc, copper, magnesium, and tin. D. Tin, magnesium, copper, and zinc.
Your answer is correct.
Which of the following elements cannot be extracted by using carbon? A. Tin. B. Iron. C. Copper. D. Aluminum.
Your answer is correct.
Metals above carbon in the reactivity series are extracted by A. Heating strongly in air. B. Heating with carbon. C. Oxidation of the metal salt. D. Electrolysis of molten metal salt.
Your answer is correct.
Which word equation is correct for the extraction of tin from tin ore using carbon? A. Tin reacts with carbon to form tin 4 oxide and carbon dioxide. B. Tin 4 oxide reacts with carbon dioxide to form carbon and tin. C. Tin 4 oxide reacts with carbon to form tin and carbon dioxide. D. Tin reacts with carbon dioxide to form tin 4 oxide and carbon.
Your answer is correct.
Which of the following statements is not true about the importance of the reactivity series of metals? A. Able to identify ways to store the substances. B. Able to identify the method of extraction for metals. C. Able to predict whether a reaction can occur. D. Able to predict the physical properties of elements.
Your answer is correct.
The diagram shows the extraction of tin from ores using the blast furnace. Answer the following questions about the extraction of tin from tin ore. 1. State the common name given for tin ore. Cassiterite. 2. What substances are mixed in stage 1? Tin oxide or tin ore, calcium carbonate, carbon. 3. Explain why carbon is used in the extraction of tin from tin oxide. Carbon is more reactive than tin. Carbon will extract oxygen from tin oxide. 4. Write the word equation to show the reaction between tin ore and carbon in stage 2. Tin oxide reacts with carbon, produces tin and carbon dioxide. 5. Explain how slag is formed in stage 3. Calcium carbonate will decompose into calcium oxide, and this will react with impurities to form slag.
In this lesson, you have learned about the reactivity series of metals and its importance. We could identify the position of metals in the reactivity series by the method of extraction. We view the process of extraction of metals using carbon. We discuss the importance of the reactivity series of metals. Metals at the top of the series are more reactive than the metals below them. Carbon is placed in between aluminum and zinc in the reactivity series. The extraction of metals above carbon in the reactivity series is done through the process of electrolysis. Carbon is more reactive than the metals below it in the reactivity series. The extraction of these metals from its ore is by using carbon. Metal oxide reacts with carbon to produce metal and carbon dioxide. Since carbon dioxide is a gas, the product that is left behind is the molten metal. Metal oxide reacts with carbon, produces metal and carbon dioxide. The reactivity series shows us the reactivity of metals towards oxygen. Knowledge about the reactivity of metals will tell us how to store them. The reactivity series will also enable us to predict whether a reaction can occur.
Galena or lead sulfide is a common and popular mineral for rockhounds. It is a natural semiconductor which is used in electronic gadgets and medical equipment. Click the Info button to learn the physical properties of galena. Color is lead to silver gray. Luster is metallic to dull. Transparency crystals are opaque. Crystal habits, shape, include the cube, octahedron, and combinations of the two. Cleavage is perfect in four-direction forming cubes. Fracture is uneven and rarely seen because of the perfect cleavage.